Find all absolute extrema of f of x equals to 6x squared e to the negative x on the closed interval negative 2 to 4. Now, usually when you are being asked for absolute extrema on a closed interval, the way you do it is first identify the critical numbers and then evaluate the function at the critical numbers and at the endpoints. And among those values, you just pick the highest and the lowest. Those are your absolute maximum and absolute minimum. However, if your function has exponential functions or logarithms, sometimes it's hard to compare which is higher than the other, unless you have a calculator, of course. But if such a question is given in a non-calculator section, you have to resort to other means to actually figure out which is the highest. Okay, so let's try this. First, we have to identify the critical numbers. Critical numbers are where the derivative is equal to 0, so we're going to differentiate the function. And you can see that it's a function, it's a product of two functions, 6x squared and e to the negative x. So you must use the product rule. So let's use the product rule. Without using the product rule, this is the wrong derivative. You have to use the product rule. And then 6x squared, x squared differentiates to 2x. 2 times 6 will be 12x. So it's 12x, and then e to the negative x. Plus, and here you have 6x squared, and the derivative of e to the negative x is negative e to the negative x. Now, why is that? Let me just make a quick remark there. So, if you differentiate e to the negative x, you can think of this negative x as a big X, right? And if you think about e to the big X, e to the x differentiates to e to the x, right? Where this big X, by big X, I mean the negative x, right? So it's this. And whatever you covered by the big X, that's the inside function. So this negative x is the inside function, which you bring it outside. You make a copy of it outside and you differentiate. And because negative x differentiates to negative 1, you end up with e to the negative x times negative 1, which is equal to negative e to the negative x. That's why I get this. And then furthermore, I see that these have the common factor e to the negative x. So let's simplify. There are many questions you may have solved that does not require algebraic simplification, but you know, when you have to use the derivative for other purposes, you do have to know how to simplify it. Okay, so we're going to simplify by factoring the e to the negative x, which leaves you with 12x minus 6x squared. I still see that x is a common factor and 6 is also a common factor, right? So I'm going to factor the 6x out. That leaves you, well, 6x times 2 is 12x, so it's 2. 6x times x is 6x squared, so that's x e to the negative x. And then we have to figure out when this is equal to 0, because critical numbers are places where this is equal to 0. So we write down 6x, 2 minus x, e to the negative x equal to 0. And when is it equal to 0? Well, that's 0 and 6x is 0, in which case x is 0. And or when 2 minus x is 0, in which case 2, by adding x both sides, x is 2. And e to the negative x, well, exponential functions are never 0, so here you don't get any solution here. So what I get is that the critical numbers are x equals to 0 and 2. Okay, and then along with these endpoints, we have the endpoints are negative 2 and 4. So we have to evaluate this function at these 4 points, -2, 0, 2, and 4. So let's try that. First, well, let's do on a new page. Okay, so we need to evaluate at f of -2, f of 0, f of 2, and f of 4. Those are the points that we have to evaluate. 0 and 2 are the critical numbers. -2 and 4 are the endpoints. -2 and 4 are the endpoints of the interval. When I plug in -2, this is what I get. You get 6 times -2 squared e to the negative of -2, which is 4 times 6. That's 24 times e squared. Okay. And then f of 0, that's easy, 6 times 0 squared e to the -0th power. But 0 squared is 0. 0 times anything is 0. So that's 0. F of 2 is 6 times 2 squared e to the -2. So that's 24 e to the -2. And then finally 6 times, you have 4 squared e to the -4, and that's a big number. 16 times 6, that's 96 e to the -4. Okay. Alright, so I know immediately that this is the lowest, right? Everything's positive, so this is the lowest. So this is absolute minimum. Okay, so absolute minimum is at 0, 0. Okay. However, of these three values, I'm not so sure which is bigger. Okay. So what should I do? Well, here's one thing that I see. I see that 24e squared is, 24, what's 24e -2? This one. This one is 24 over e squared, because the negative power means you have the reciprocal, right? So since e is about 2.7 squared, that's a big number. It's close to like 8. And so 24 times 8 is of course bigger than 24 divided by 8. So this is definitely the bigger one. Okay. What I'm not so sure about is, what about these two, or maybe these two, right? So since this is lower, this cannot be the absolute maximum. So we can only have absolute maximum as 24e squared or 96 e to the -4. I have no idea which one is bigger. And that's why in some cases you need to draw the number line and evaluate the f prime at some test points. So let's see, you have -2, and then 0, and 2, and then 4. We know that at 0 and 2, f prime is 0, right? But what is the sign of f prime at a test point between 2 and 4? Because if I just look at the test point, that can tell us whether f is increasing or decreasing. So let's do that first, and then I'll keep explaining. So I'm going to choose 3 because 3 is right in between 2 and 4. And remember, f prime of x, we had it as 6x times 2 minus 4 times e to, sorry, not 2 minus 4, 2 minus x e to the -x, right? So what is f prime of 3? That's 6 times 3, 2 minus 3, e to the -3. Remember, exponential functions are always positive. This can never be 0. 6 times 3 is positive, but 2 minus 3 is -1. So overall, this is negative, because you have a negative times positive and positive. So we know that f prime is negative here. And the beauty of the test points is that once it's negative in one test point, then in this interval, before it hits the endpoint or the critical numbers, in this interval, f prime is always negative. Okay, it cannot change the sign. That's the beauty of these test points. And once you have these test points, then you can say because f prime is negative, then f would be going down, because see, f prime is the rate of change. If the rate of change is negative, that means f is decreasing, right? So we know that f is decreasing. Now what does that mean for us? It means that 24e negative 2, from this value up till until 96e to the negative 4, it's actually decreasing, because that's what we just figured out. From 2 to 4, it's decreasing. So 24e to the negative 2 must be bigger than 96e to the negative 4. Maybe I should write that down. Okay. Since f of x is decreasing on 2, 4, 24e to the negative 2 is bigger than 96e to the negative 4, because this should be higher value. Decreasing means it goes from higher to the lower value, right? So here is what we just figured out. 24e squared is bigger than 24e to the negative 2, and this is bigger than 96e to the negative 4. So the conclusion is that this is the largest. Okay, so this would be now my, so after this argument, we know that now that this is the absolute maximum. So absolute maximum is negative 2 comma 24e squared. Okay, so that's the answer, and I drew the graph just to assure you why this is true. Here's the graph that's actually drawn. So you see that at 4 and at 2, this is 24e negative 2, this is 96e to the negative 4, and definitely this decreases, so this is smaller. And at negative 2, this is so large it's not shown in the graph, but that's very, very big. Okay? And the answer is absolute max is negative 2 comma 24e squared. Absolute minimum is 0 comma 0. Now notice that I'm writing both coordinates for absolute max and absolute min. You really need a pair of coordinates x comma y for these answers to absolute max, absolute min, relative max, relative minimum. Okay, and just to add to the solution, although the question was not asked about relative maximum, this point here, as you can see in this graph, is relative maximum, right?